So I'm going to be talking about agroecological zones, or classes, as you will. And this is part of Objective 9 and part of the integrative, some of the integrative goals of the overall project. And I'm going to touch a little bit on dynamic agroecological classes and charting cropping system shifts and changes. And this work is the result of a team, and I've listed them there, from basically many of the people on the project. And the map you see there is comprised of some of the different land uses. This is derived from the cropland data layer that's produced by NASS every year. And so by using that cropland data layer, you have data that you can evaluate to assess changes that occur. So one of the things that we did right off the bat was see if we could look at our agriculturally productive regions and use that cropland data layer and some very simple criteria to classify those different pixels. And so what you're looking at are 57 or 56 meter squared pixels that have been classified as to what agroecological class they belong to. And this was done simply on the basis of the proportion of fallow surrounding each of those pixels. So annual cropping, we're pretty much cropping over 90% of the time. There's a annual crop fallow transition where we have a larger proportion of fallow in the pixels surrounding each pixel, up to almost 40%. And then we have, if we're above 40% fallow, we classify that as an annual grain fallow type of cropping system. So each pixel across the region was classified, and this is how it turned out. For irrigation, we used annual cropping, but under dry conditions. So there was an additional criteria there used for that. So very simple criteria, all based on the cropland data layer, a data layer that's produced every year. And this allows, again, creation of these kinds of maps every year. So we had them from 2007, and the one for 2013 just came out. So, and I know Rick Rupp has been busy already classifying those data layers, and Rick has worked quite a bit from the GIS perspective. This is what the maps look like. The reason I call these classes instead of zones is that I haven't put any lines around anything. So all you see is the result of the classification of each 56 meter squared pixel. And you'll note that for the different colors here, this is the annual, these blue pixels classified as annual cropping. The yellow is this annual crop fallow transition. And you notice that that kind of falls out, as you might expect, along a rainfall gradient. This red is the grain fallow portion of the classification. And you'll notice that there's yellow here in kind of, as the precipitation no doubt falls below about 18 inches or so, we're going to be assessing that, and fallow is starting to be included. But interestingly enough, we also have up on the Camas Prairie, under high rainfall, also fallow being used. And this comes into play when we start to have issues in the spring trying to plant our crops. And so it's interesting to see that the strategies that play out across the region, we can assess these every year, and consequently look at some of the dynamic. How consistent do the classifications for any given pixel remain over these courses of years? And this is what this map is depicting, is basically, okay, of 5 years in this case, 2007 through 2011, how many of the pixels classified the same way every 5 of those years? And then in turn, 4 out of 5, 3 out of 5. And so that's what these different colors represent as you're going from light purple, say, to darker purple. That means that we've had the darker color in each case means that we have less of the years, 3 out of 5 in that case, that we're classifying consistently over time. And this allows you to start to identify transition areas where there's kind of shifts. And here's one here between the annual cropping and the annual crop fallow transition. And you can see that there's movement back and forth along some of these kind of boundaries that we'll see between these major overall classes. And again, you'll see more of that here, and in terms of that transition. So this then starts to give us some tools to look at from the standpoint of how these different zones switch. We can start to pose hypotheses in terms of trying to understand why are these shifts happening. Is it driven by weather or prices in terms of economics, et cetera. And so I think that's one of the things that can be done from the standpoint of using these kinds of data and analyses. But also you can assess what's occurring from the standpoint of the crops that are being grown in any given agroecological class. So you can go in and say in the annual cropping, and this is the data you see on the right here, we can see from 2007 to 2012, in this case, changes in number of hectares of different crops that are grown. And I've just highlighted here the legumes. Chickpeas went from almost doubled from the standpoint of their production. Lentils kind of went down a little bit but held steady, and peas went up a little bit as well. So the legumes have had a resurgence, at least from using 2007 as a baseline to 2012. Obviously, this type of analysis could be conducted every year that we have these data, which is every year since 2007. The expectation is that these kinds of data will be available in the future. And then from the standpoint of oilseeds that are found in terms of the classification scheme, and I'll just point out some of the canola acres almost tripling from the standpoint of going from 2007 to 2012. And so, I know, and many of you are aware of, that there's been a real emphasis on trying to promote biofuels, and canola being one, and camelina as well to a certain extent. These kinds of assessments help us to track a little bit not only the hectares that you see here in terms of the total area used for these crops, but we can also look at it spatially. Where are these changes taking place from the standpoint of these crops? So that's a little bit of here in terms of looking at the 2007 and 2012 for just the grain legumes, and here's the overall map of where those are grown. So here's all the pixels where they actually had a grain legume being grown in that 56 meter squared area. And then we can look at it here in this kind of blurry place in terms of the reddish to the greenish kind of representing then some of the shifts in terms of where those were actually grown there. Again, this type of analysis lends itself to posing different hypotheses in terms of trying to explain what these kinds of patterns mean from the standpoint of what the growers actually did on the ground that particular year. So that's a big part of Harsimran Kaur's PhD work, is to try to assess some of this, and also continuing on with some of her work is to also, once we've actually identified these kinds of classes on the ground, we could start to link it to different kinds of variables that might be able to explain why we find a particular agroecological class in an area versus another. And so this is basically linking then these AECs to what we're calling bioclimatic variables. In other words, in particular, when we're looking at climate and climate change, what are those kinds of variables related to climate that we'll call bioclimatic variables that are impacting, in this case, our crops, but also could be used in the context of a lot of different kinds of biology that's occurring across the region. And so Harsimran has been assembling different bioclimatic variables that we think will be fairly powerful in predicting where these different AECs exist, and perhaps some of the dynamic within them as well. Much of them are related to temperature and precipitation. So water supplied to complete life cycle, human indices, growing season length, heat requirements, extremes tolerated in terms of temperature and water. And if we do come up with these kinds of variables, it'll be interesting to see if we can then use future climate projections to actually predict what is our expectations in terms of how some of these AECs may change. All this we're hoping to link to the CropSys model in terms of looking at developing crop year prediction maps based on combination of historic and current production year weather data for AECs. We think this will be real useful for growers in order to see for different crops, not just wheat, but other alternative crops, what's occurring across the region, using the CropSys model to predict those yields, and also to use the model to identify in those transition areas in particular what might be going on in terms of choices. Also links to the biotic monitoring, and with that, I think I'm done.